All right, so it's a little rush before because I knew the video was going to end. I'm going to kind of back up a little bit. So what we found with this, the purpose for finding this is we're actually finding the price point of our maximum revenue. So it means that if it's a little bit more as far as per unit, they're actually going to make less in revenue. If it's a little bit less, they're going to make less in revenue. So what we found here is that the ideal price point is $30,000. And now let's find the maximum profit using our equation, which was our negative 500 p squared plus 30,000 times p. So if we now put that maximum into these areas, we get negative 500 times 30 squared plus $30,000 times that $30, and we get an answer of $450,000. So our maximum revenue is going to be $450,000, and that's when selling the units at $30 per piece. Let's go ahead and look at the graph. And you can see here that I've already put the function equation in here. So I put it in. Our revenue function was our negative 500 p squared. I've got x squared that you use here where it says link. You're going to use x plus 30,000 x, which is my p, and then I graph it. So now if we're to look at this, I hope you can see the pointer on here. The maximum revenue is right here at the top of this particular value. And price point wise, if we were to come straight down, that is our $30 per unit price. And here identifies that that tip of our revenue equation is our $450,000. You can see that as we get higher in price, we're going to sell less, so our revenue is going to be less. And when it's less expensive, we're going to sell them, but we're not going to quite make that maximum profit that we would at the $30 per unit. All right, so for the you-do, I want you to press pause, go ahead and solve this, and come back when you're ready. Okay, so the question is, use the graph from example 3, would the price yield higher revenue at $28 or at $40? So if we actually look at this, what we're going to do is we're going to go to our graph and we're going to hit trace. And I'm sorry I have to keep kind of going back every time I go out of it, so let me get back to our graph. And now we're going to hit trace. Now you can see down below here where it has x equals and y equals, those are those price points. If we follow along with it, you can see here the price point at $42. What we're going to do is get as close to 42 as we can. So it's kind of between here at our 41.70 and our 42.45. So somewhere in there, and I'm looking at anywhere, if you look at that y of 381,000 to 372,000. So I'm looking at a profit of around $375,000. I kind of cut the difference between when the price point is at $40. So now if we keep tracing and we come back over to the other side, and I am just hitting our arrow. I'm going to show you right here, this arrow here to the left. And now we're getting to a value of 28. And you can see here, I'm looking anywhere between 447,000 and 448,000. So, for that value, 447,000, we'll say 500 with the price point at $28. And the question is, which price would yield the higher revenue? 447,000 beats 375,000. And so $28 would actually yield a higher level or a higher level of revenue. So it's not always good to make it more and more expensive. Some of you might wonder, like, how do they decide, you know, when they do that, or what's too much, or is there too much? Well, there is, because again, we've talked about this before. You might spend $5 for that hamburger, but you're not going to spend $15. So experts come out and they figure out what is that maximum revenue price point. What will most people pay to where we can maximize our revenue, and when did we go overboard, and when are we selling it for less money? All right, last example. It says the revenue and expense functions are graphed on the same set of axes. So we actually did this. We did the expense function in example 1, and we did the revenue function in example 3, and now we're comparing them. And it says the points of intersection are labeled A and B. Explain what is happening at these points. So you can see right here I have A, right here I have B. And what this is this is called our break-even points. And just like it sounds, it's where you break even. It's where your expenses equal your revenue. So, how much you've spent equals how much you've earned. At this point, there has been a zero profit at either of these breakout points or break-even points. And so the two break-even points here, if they were to sell this unit at $8.08, they would break absolutely even. If they sold it at $58.92, they would break even. So the idea, obviously, is again to find that point, which we already did, coming down. That was that $30 point. All right, last you do. Press pause. Go ahead and solve this and come back, and we'll answer it together. Okay, it says, why is using the prices of $7.50 and $61 not in the best interest of the company? So let's go back. We were talking about $7.50 and $61. Let me kind of erase this so we can see a little bit here. $7.50 first is going to fall somewhere about right here. And what's happening here, you can see this is my expense line and here is my revenue line. So at this point, expenses are higher than the revenue. They're losing money. And subsequently over here on this side, anything here, 61 is about right there. Again, it is lower than that revenue curve. And so both of these situations are in a case where the company is losing money. So that is why it is not beneficial. So here's the thing, if we hopefully interpreted this well. From these points here, anything above that expense function, here we're making money. We're making revenue. In our break-even points, we made nothing. Except to cover expenses. And then finally, any area down here below the curve, we're losing money. And that's it for this unit. Good job, everyone.